Drawing best practices. We have learned about commonly used standards as applied to engineering drawing. We shall now in this topic learn about some generally used best practices as applied in different industries. These practices will be explained through various examples for your understanding. Dimensions only critical and measurable features. In majority of the industrial drawings today, all dimensions can be derived from the 3D model. Therefore, only critical inspection dimensions and threading information are needed on the 2D drawing. On almost all production lines, it's assumed that all dimensional callouts in the drawing require inspection. These dimensions are measurable by hand metrology tools such as calipers, micrometers, and pin gauges, etc. Some typically measurable dimensions are as follows. Parallel outside dimensions, parallel inside dimensions, depth, hole bore diameter. While some examples of dimensions that are sometimes provided but are not measurable directly with hand tools are as follows. Hole center to edge distance, hole center to center distance, distance between non-parallel surfaces, radius between surfaces. Note: dimensions should not be placed in the area of the model but always outside of the model. Also, do not dimension to hidden lines. Communicate hole tapping needs with thread size and depth. Thread depth is hard to measure exactly, therefore, the depth callout is always treated as a minimum. Drilled holes depth is only dimensioned if it is important for the part functionality. When using coarse threads, there is no thread pitch indicated. Only when using fine thread pitch is indicated. Consolidate callouts when multiples of the same feature exist in a view. Dimension only one of the similar features and label the dimension showing that the feature exists in a view multiple times. For example, 4 into 10 to 32 tap implies that in the view there are 4 10 to 32 threaded holes. Communicate assembly intent of critical features. Let us consider an engine assembly. If an entire assembly is being machined, provide an assembly drawing or instruction. Alternatively, if you will be installing off-the-shelf standard components or hardware in piston or connecting rod assemblies, provide the part number of standard part so that the worker can look for those parts. Leave optional secondary operation callouts off the drawing. If secondary operations such as polishing or anodizing are optional, not critical, it's best to request a quote and lead time for those add-ons separately. So you know the additional time and cost, especially during the early stage of development and prototyping. Similarly, if you are unsure of what material to use or are trying a few different materials, leave material off the drawing so that it doesn't cause confusion in production. Note, however, as we approach near the final stages of production release, these details becomes important for product quality. Tabular dimensions, dimensioning multitude of similar features. When there are many drilled holes in the part, it is impractical to draw all dimensions then the following method is used. A coordinate system is found for drill holes locations. Each one of them is noted with a letter and a number. Each group of same type of holes get the same letter. A table should be added to indicate the drill hole size, number of drill holes, holes location coordinates of XY, and the required tolerance. Don't over-dimension or over-tolerance your designs. Typically, only a few features on a part are critical to its function, so you want the machinist to pay extra attention to these features. When you over-dimension, the critical requirements are lost in the noise, so assign only tolerance to mission-critical features. Over-dimensioning will also drive up the cost of prototype. Don't require tolerances that fall below standard hand metrology tools' accuracy capabilities. For reference, the tools that are normally for measurement have the following accuracy. Caliper plus minus 0.02 mm measures outside dimensions and depth. Micrometer plus minus 0.01 mm measures outside dimensions and bores under 25.4 mm. Pin gauges plus minus 0.02 mm increments measures holes diameters. Holes between 5 mm and 25.4 mm will be verified with a telescopic bore gauge and micrometer. Bores larger than 25.4 mm will be measured by a caliper. Don't automatically expect all geometrical dimensions and tolerancing controls to be inspected. Usually, it is discouraged to use geometrical dimensioning and tolerancing controls to communicate design requirements. We appreciate the system efficiency compared to traditional linear dimensioning. However, some GD&T's control can't be easily verified with hand metrology tools, which is the standard in quick turn prototyping. We commonly see the following GD&T control symbols on prototype drawing: flatness, profile of a surface, true position applied to center of holes and bosses. Note, standard practice is to skip inspection of these callouts unless a machine shop is specifically instructed to provide a coordinate measuring machine inspection report, which may add several $100 and extra days of lead time. Drawing best practices. With understanding of some commonly used best practices, along with application of certain established standards, shall enable you to create or develop engineering drawing which conveys consistent and uniform information to all users of such a drawing. Interpretation of drawings. After learning standards and best practices used in industries, let us now understand as an end user how drawings are interpreted and read in industries. These practices will be explained through various examples for your understanding. Start by looking at the title block on each drawing located in the lower right of the drawing. The title block contains designer's name in case of manufacturing drawing or the architect in case of civil drawing. The drawing number, project name, part number, and the scale of the drawing. This will help you understand what you are looking at. Parallel projections include orthographic drawings, which consist of a front view with the top of the object drawn below the front and a drawing of the side view placed to the side. Note, these drawings are drawn in either parallel or perspective projections. The drawing of the front of the object shows dimensions of width and height. The drawing of the top shows width and depth, and the side shows height and width. Perspective projections are drawing in which an object is drawn using 1, 2, or 3-point perspective. Take below example of civil drawings. These drawings present the subject as a three-dimensional object. Section views show the hidden features of an object so that a craftsman in manufacturing drawing or builder in case of civil drawing can completely understand how the piece is shaped inside and out. In manufacturing drawings, exploded views show the pieces that make up a given object outside the object. Connector lines indicate where the pieces go and how the unit is assembled. Projection and dimension line. Projection and dimension lines are drawn in or around the outline of the subject and are used to indicate measurements and instructions. A projection line is drawn in alignment with the edges of the subject in manufacturing drawing or with a section such as the edges of a window or chimney in case of civil drawing. These are used to indicate the width of the indicated section. A dimension line is drawn from one projection line to another with arrowheads touching each projection line. Measurements are noted on dimension lines to describe what size materials should be. Reading symbols. Manufacturing drawings use various symbols to denote tolerances and type of dimension, finish, and references, etc. Architectural symbols are used for doors and the way they open, windows, stairs, appliances, fixtures, and furniture. These symbols are generally notated. Other types of symbols used in architecture, landscaping, and manufacturing denote the types of materials being used in the construction of a unit, part or section that is marble, brick, wood, plastic, steel, etc. In civil drawings, electrical outlets, cables, and wiring along with the ductwork are also included in a plan. Oftentimes, a separate drawing, such as detailed electrical drawings, can be on a lighter paper that is overlaid on the main drawing. Some notation might be included in other views of the subject. Interpretation of drawings. With understanding of how drawings can be interpreted, you would appreciate importance of standards as it ensures consistency and uniformity across organization.